This video demonstrates how to enter data from an example project site into NCDOT JSLAT. The example presented in this video is a relatively simple site with one BMP. After you have determined that your project meets the rule criteria, have gathered the necessary project data, and created the post-development site plan, you can begin entering data into NCDOT JSLAT. For this tutorial, our example site is an NCDOT facility that contains a couple of small buildings, uncovered material storage, parking lot and driveways, open space, and forested areas. Our project area is delineated in red. Runoff on the site drains to the east and leaves the project area at the east boundary. This image shows the delineation of the pre-development land cover. And this image shows the post-development land use delineation. For this hypothetical project, we have one proposed BMP. The drainage area for the BMP has been delineated in green, and both pre- and post-development land use areas have been delineated and tabulated for the site. Note that the southern portion of the project area does not drain to the proposed BMP, but has been included as part of the project site because land cover changes are proposed for that area. Our hypothetical project has a hydrologic soil group of A, underlying the majority of the project area. Land use data for the site's drainage area is entered in the Watershed Characteristics tab. Let's begin by selecting the Piedmont physiographic region using the drop-down menu. Select the A soil hydrologic group. Select the Burlington precipitation location as the most representative weather station. Enter the total drainage area for all the catchments. Next, we will enter a name for the site here, and enter your name or your initials here. Next, we will enter the delineated land use areas. Our site is located in a predominantly non-residential area, so we will enter the data in column 1. Do not enter land use data into both columns 1 and 2. The example project is an industrial site consisting of multiple land uses. I will enter the pre-development land uses first. Empty cells are treated as zero area in NCDOT JSLAT. Next, we'll enter the post-development areas. JSLAT warns us that the areas do not yet match. This box displays 3 different areas: the value we entered at the top of the tab, the total area we entered for pre-development, and the total area we entered for post-development. Our areas do not match because we have not yet entered the proposed BMP area. So let's do that now. We see that the wording has disappeared and that the 3 values on the right now match. We have completed the Watershed Characteristics tab. Now is a good time to save the model. Now we can proceed to the BMP Characteristics tab by either clicking on the tab itself or by clicking the Proceed to BMP Characteristics button. Land use data for each BMP drainage area is entered in the BMP Characteristics tab. Our example site only has one BMP, so all of the data will be entered under Catchment 1, BMP number 1, which corresponds to BMP A on the site map. The BMPs in this example will be sized according to the NCDOT toolbox, so we can leave this row blank. Some BMPs may be undersized due to limited space. In those instances, enter the appropriate value for each BMP here. This project only has one BMP, so leave these values set to no. If another catchment that was part of this development project discharged into the BMP A drainage area, then we would adjust these values as appropriate. Next, enter the post-development land use area that is within the drainage area for BMP A. Empty cells are treated as zero area. Next, enter the area of the BMP itself. In any land use category, if we enter a value that is larger than what was entered in the previous tab, NCDOT JLSLAT will provide a warning. Select Retry and re-enter the correct value. The bottom shows the total area for BMP A and catchment number 1. Our site has no other catchments or BMPs, so we leave the rest of this tab blank. To the far right, we see 2 additional columns. The right column lists the total area for each land use category. Values in this column correspond to the data entered in the Watershed Characteristics tab. The column to the left is a summation of the area entered on this tab only. For this example, these 2 columns will not match, since there was a portion of the project area that does not drain to a proposed BMP. The far right column must be greater than or equal to the column to the left. If not, JLSLAT will notify the user if a land use value is entered that exceeds the amount entered on the Watershed Characteristics tab. Now that we have finished entering data into the NCDOT JLSLAT model, we can proceed to the model results in the Development Summary tab to confirm whether the nutrient targets will be achieved. To view the model results, click on the Development Summary tab itself, or click the Proceed to Development Summary button. The Development Summary tab provides estimated runoff and nutrient levels for 3 scenarios: pre-development, post-development without BMPs, and post-development with BMPs. The top table provides pre- and post-development estimated loads and concentrations. In this example, the annual runoff volume changed from 153,232 cubic feet pre-development to 426,273 cubic feet post-development without BMPs to 223,371 cubic feet post-development with BMPs. Nitrogen concentrations changed from 1.49 milligrams per liter pre-development to 1.53 milligrams per liter post-development to 0.83 milligrams per liter post-development with BMPs. Nitrogen loadings changed from 2.01 pounds per acre per year pre-development to 5.75 pounds per acre per year post-development to 1.64 pounds per acre per year post-development with BMPs. Phosphorus concentrations and loadings also changed. The lower table provides pre- and post-development estimated percent differences. In this example, the annual runoff volume increased by 46% from pre- to post-development with BMPs. If no BMPs were used, then the runoff volume for the site would have increased by 178%. The use of BMPs reduced the post-development runoff volume by 48%. Similarly, BMPs reduced post-development nitrogen concentrations and loads increased by 45% and 71% respectively. BMPs also reduced post-development phosphorus concentrations and loads by 60% and by 77% respectively. If this site were located in the upper New Hope watershed, then the current post-development plan would meet respective nitrogen and phosphorus load percent reduction requirements and the loading rate requirements. Only one set of criteria needs to be met to achieve compliance. This site has an estimated nitrogen and phosphorus loading rate of 1.64 and 0.26 pounds per acre per year, respectively, which is less than the loading criteria of 2.2 and 0.82 for the Upper New Hope watershed. The bottom BMP summary table provides runoff and nutrient results at the BMP level and the catchment level. In large sites with multiple BMPs, this table can help identify which proposed BMPs are the most effective through an iterative design process. This video demonstrated how to enter data from an example project site into NCDOT JSLAT. Additional resources related to the NCDOT Green Program can be found at the NCDOT Connect site.